This problem should be solved in 3 steps. Okay, first of all, we need to know which tension do we need to apply on the string so that the block moves. Okay, so a very good idea is to make a nice drawing about everything, just like that. And there's a force going on here, and well, you need to know if the block is moving or not. You know for sure there's a friction force that goes the other way, and so on. Okay, so let's draw the free body diagram. We know that up you go, well, there goes the normal force. Down you got the weight. Right, you got the force that someone's making, and left you go the friction force. Okay, so first you need to find the force, the value of this force that you need to make like everything be in balance. Okay, so let's do that. And when we find it, we will be able to know if the 15 newtons force that's over here is enough for, to move it, or this 20 um, newtons are just like enough for moving it. Okay, so let's just do the sum of all the forces in x, and we're gonna have that we have the force minus the static friction. That's gonna be equal to 0 because this thing is in balance, and the force is in x, which are gonna be the normal force minus the weight, and we have nothing else, so there we go. And well, we need to find this tension over here. Okay, that's it. So for that, we need to remember that the friction, whether static or kinetic, is like the coefficient times the normal force. In this case, the static. So from here, we need to find first the normal force, which is the normal force is equal to the weight. Okay, so we know it's going to be 20 newtons. Oh, something that I forgot to compute is that the weight of the mass. Okay, we need to find the mass because we know the weight. So we need to remember that the weight is equal to the mass times gravity. So we know the weight. We just need to find the mass, which would be like 20 newtons over 9.81, and this is going to be 2.038 kilograms. Okay, that's a cool data that a cool fact that I need. So there we are. Now we need to substitute this stuff into the first equation of x. So we're gonna have the tension. It's gonna be equal to the static friction coefficient times the normal force. So this thing is gonna be what it was, 0.8 times 20, and this is gonna be 16 newtons. Okay, so from those results, we just know that the 15 newtons are not enough for moving this object. So I know that I need to use the static coefficient to solve this system. So for part 8, for tension of 15 newtons, I'm going to solve this. This is going to be the sum of all the forces in x. It's going to be tension minus static force. It's going to be equal to 0. And the sum of all the forces in y is going to be equal to the normal force minus the weight. And this thing is going to be equal to 0. From here, what can I do? Well, actually everything is going to be equal to this thing. So I just need to find the friction force. So from the first equation, I know that the friction force, the static friction force, is going to be equal to the tension. So I know that this is going to be equal to 15 newtons. And there we go. That's part A. And for part B, well, I need to resettle all my equations. And for the tension of 20 newtons, I'm gonna resettle my equations, which are like sum of all the forces in x. It's gonna be tension minus this kinetic friction force. That's going to be equal to mass times acceleration. And yep, pretty much. And the sum of all the forces in y is going to be equal to the normal force minus the weight, and it's going to be equal to here, 0. So once again, I noticed that normal force is going to be equal to the weight, which I already know. So we now need to find the acceleration to find this friction force. Okay. Well, from there I know that the tension minus minus the mu k times the normal force is going to be equal to the mass times acceleration, and from there I know that the acceleration is going to be equal to the tension minus the mu k times the normal force, which is equal to the weight, and this goes over the mass. Thus I know that this is 20 minus 0.6 times the weight, which is 20, over 2.038, and this is going to be equal to, if I'm wrong, 3.9 meters over second squared. Okay, so from here I just know everything I need to find the total friction, the kinetic friction. So I know that friction is going to be equal to, I'm getting all this from here, kinetic friction is going to be equal to mass times acceleration plus the tension, and from there I just know that this is going to be mass acceleration, yeah, this is going to be the 20 newtons minus the mass times acceleration, that is 2.038, which is the mass, times 3.9, and this is going to be equal to 12 newtons.